Next is question number 81, which says that a man starts from the point A, that is 1, 2, 3, and reaches the point B, that is 5, 8, 11, after touching the plane x plus 2y plus 3z equal to 0 at C. Then the minimum length of AC plus CB is. So this is also a good question. Let us say that this is the plane, right? Now a man starts from the point A, that is 1, 2, 3, and he reaches the point B, that is 5, 8, 11, after touching the plane. Now to get the minimum value of AC plus CB, we have to make sure that this is the incident ray and this is the refracted ray. That is, these two angles will be equal. So we can say that the image of A, let us say that is A dash, right? C and B should lie in one line. So let us firstly find the image of A in the given plane, that is x plus 2y plus 3z equal to 0. So the image can be found as x minus 1 upon 1 equal to y minus 2 upon 2 equal to z minus 3 upon 3 equal to minus 2 times a into x1, that is 1 plus 2 to the 4 plus 3 3 is a 9 upon 1 plus 2 whole square plus 3 whole square, that is it is equal to minus 2. Now from here the coordinates of A dash can be found as x will be equal to 1 minus 2, that is minus 1, y will be equal to 2 minus 4, that is minus 2, and z will be equal to minus 6 plus 3, that is minus 3. Now we have to find the minimum length of AC plus CB, which will be equivalent to finding the length of A dash C plus CB, because A dash C will be equal to AC, right? Now as A dash C and B are collinear, so we can see that A dash C plus BC will be equal to A dash B. Now by distance formula we can find the value of A dash B equal to under root of 5 minus minus 1 whole square, that is 36, plus 8 minus minus 2 whole square, that is 10 whole square, that is 100, plus 11 minus minus 3 whole square, that is 14 whole square. So this will be equal to under root of 332. So the correct answer will be option number 2. Next is question number 82, which says that the solution of differential equation x plus phi equal to cos inverse dy by dx is. Now to solve this differential equation, we know that we have to solve it by substitution method. That is, let us assume x plus y equal to t. So differentiating it with respect to x, I get 1 plus dy by dx equal to dt by dx, right? So writing x plus y as t, this is equal to cos inverse dy by dx, that is dt by dx minus 1. Now further this can be written as cos t equal to dt by dx minus 1, that is dt by dx can be written equal to 1 plus cos t, that is 2 times cos square t by 2. Now this can further be written as integration of secant square t by 2 into dt equal to integration of 2 times dx, right? So this will be equal to, we know that integration of secant square t by 2 will be equal to tan of t by 2 into 2, which will be equal to 2 times x plus c. Cancelling 2 on both sides, we get tan of, as t is equal to x plus y upon 2. So this is equal to x plus constant c, right? So the correct answer is option number 2. Next is question number 83, which says that the equation of a curve whose slope at a point x comma y is minus of x plus y upon x and which passes through the point 2 comma 1 is. Now the equation of a curve whose slope is given as this. Slope is given by dy by dx, right? So basically we are given dy by dx equal to minus of x plus y upon x, right? Which can be written as minus of 1 plus y upon x. Now this can be written as dy by dx plus y by x equal to minus 1. Now here we know that dy by dx plus py equal to q. इससे अगर हम comparison करें then we can see that p is equal to 1 by x and q is equal to minus 1. Therefore integrating factor will be equal to e raised to the power integration of p into dx, which will be equal to e raised to the power ln x, that is which is equal to x. Now the solution will be equal to y into integrating factor equal to integration of q into integrating factor, that is minus x into dx. Right, we can get that yx is equal to minus of x square upon 2 plus constant, that is we get 2yx equal to minus of x square plus c dash, right, that is we get that x square plus 2yx is equal to constant c dash. Now we know that the curve is passing through the point 2, 1. So putting the value here, we get 4 plus 2 into 1, that is 4 is equal to c dash, that is the value of c dash is equal to 8. So we get from here that x square plus 2yx is equal to 8. So the correct answer is option number 3. Next is question number 84, where it is given that if fx is a function such that x into integration of 0 to x 1 minus t into ft into dt is equal to integration 0 to x t into ft into dt and f of 1 is equal to 1, then f of 2 can be. Right, now a equation is given here. If I differentiate the given equation with respect to x, so let us find what we get here. We have two functions here. So firstly let's keep x constant and differentiating the second term, we will get 1 minus x into fx plus keeping the integral constant, differentiation of x will be 1, right? On the right hand side we get differentiating this, we will get x into fx, right? Now this term will get cancelled with this term. So basically from here we get that minus of x square into fx plus integral from 0 to x 1 minus t into ft into dt is equal to 0. So let us again differentiate this. So this is equal to minus x square keeping constant, differentiation of fx will be f dash x minus fx keeping constant, differentiation of x square will be 2x plus differentiation of this integral will be equal to 1 minus x into fx equal to 0, right? So from here we get that minus x square into f dash x, incorporating this term into the third term, we will get 1 minus 3x into fx equal to 0, right? Now it can be rearranged as 1 minus 3x into fx equal to x square into f dash x. That is, it can be written as 1 upon x square minus 3 upon x equal to f dash x upon fx, right? Now integrating both sides, what we get? On the right hand side we will get ln of mod fx, right? This will be equal to integral of 1 by x square, which will be equal to minus 1 by x minus 3 times ln x plus constant. Now we are given that f of 1 is equal to 1. So putting x equal to 1, we will get that ln of f of 1, which is 1, that is ln 1 equal to minus 1 minus 3 times ln 1 plus constant. Now these both will be equal to 0. So from here we get that value of c is equal to 1. So here I am writing it as 1, right? Now to find the value of f of 2, let us put the value of x as 2. So we will get from here that ln of f of 2 mod will be equal to minus 1 by 2 minus 3 times ln 2 plus 1. So from here we get that ln mod f of 2 is equal to 1 by 2 minus 3 times ln of 2. That is, from here we get that f of 2 is equal to e times 1 by 2 upon e raised to the power 3 into ln 2. So, which can further be solved as f of 2 equal to e raised to the power 1 by 2, that is under root e upon e raised to the power ln of 2 raised to the power 3, that is 8, right? So this is equal to root e upon 8. So the correct answer is option number 2. Next is question number 85, which says that consider the differential equation x square into dy plus y minus 1 by x into dx equal to 0. If y of 1 is equal to 1, then y of 1 by 2 is. So here it is given that x square into dy plus y into dx minus 1 by x into dx is equal to 0. That is, dy by dx plus y upon x square minus 1 upon x cube is equal to 0. Right, so here we can see that it can also be written as dy by dx plus y upon x square equal to 1 upon x cube. So here we can see that p is equal to 1 by x square and q is equal to 1 upon x cube. Right, so the value of integrating factor will be equal to e raised to the power integration of 1 upon x square into dx, which will be equal to e raised to the power minus 1 by x. Right, so it will be equal to y into integrating factor equal to integration of q into integrating factor, that is e raised to the power minus 1 by x upon x cube into dx. Now to solve this integral, let us put minus 1 by x equal to t. So differentiating this, we will get 1 upon x square into dx equal to dt. So this can be written equal to integral of e raised to the power t into minus t into dt. Now we will solve this by AIATS. Okay, now differentiating this and integrating this, it can be written equal to, taking minus sign common, we will get t times e raised to the power t minus integration of e raised to the power t, that will again be e raised to the power t. Right, so this can be written equal to e raised to the power t minus t times e raised to the power t. That is, from here we get that y into e raised to the power minus 1 by x is equal to e raised to the power t, that is minus 1 by x minus t, that is plus 1 by x into e raised to the power minus 1 by x plus constant. Now here it is given that y of 1 is equal to 1. So putting x and y both equal to 1, here we get that e raised to the power minus 1 equal to e raised to the power minus 1 plus e raised to the power minus 1 plus constant. Cancelling these two, we get that constant is equal to minus of e raised to the power minus 1. That is, y into e raised to the power minus 1 by x is equal to e raised to the power minus 1 by x plus 1 by x into e raised to the power minus 1 by x minus e raised to the power minus 1. Let us multiply the given equation by e raised to the power 1 by x. So we will get y equal to 1 plus 1 by x minus e raised to the power 1 by x upon e. Right? So putting x equal to 1 by 2, we get y of 1 by 2 equal to 1 plus 2, that is 3, minus e raised to the power 1 by x will be 2 upon e. So this will be equal to 3 minus e. So the correct answer will be option number 1.